After the proving the existence of equilibrium under various sets of assumptions, let us return to the problem of uniqueness of equilibrium. Do you remember, in the simplest case of a pure exchange economy, nothing guarantees that equilibrium, if it exists, is unique. Take this point as the initial endowment allocation. It is surely possible that according to this price system, say P prime, there is equilibrium in the economy. But also with this second price system, there is equilibrium. Huh? So, multiplicity of equilibria is possible. Obviously, this multiplicity must be interpreted in a particular sense. It is important that this inequality holds for every positive lambda. In other terms, if the second price system is proportional to the first due to absence of monetary illusion, substantially equilibria coincide. So the real case of multiplicity of equilibria is that in which our two price systems, as in this case, are not proportional. This is clear because we consider usually only the price system which belongs to delta, and therefore two elements of delta cannot be equiproportional, they must be equal. Well, under what properties of excess demand correspondence we can obtain uniqueness of equilibrium? There are many sets of properties which have this consequence. The most important of them is nothing but gross substitutability among goods. Gross. You encounter this property in consumption theory. So, but the property can be repeated, defined also in general equilibrium theory with reference to the excess demand correspondence Z. More precisely, we should say that that good J is a substitute of good I if the following properties holds. Consider any two price systems. P prime and P double prime. And suppose that P prime, P double prime I is, for example, greater than P prime I. And P double prime K is equal to P prime K for every K different from R. In other terms, when you pass from the first to the second price system, the price of good I increases while all the other prices remain unchanged. Then, for every Z prime in large Z of P prime, for every Z double prime in Z of P double prime, Z double prime J is greater than Z prime J. You remember this property? When the price of good I increases when all the other prices remain unchanged, the excess of demand of good J increases as well. This typical case of rivalry in consumption. You remember from the first part of the course, with two goods satisfy the same need, and when the price of one of them increases, it is convenient to satisfy the same need by using a greater quantity of the other good. Obviously, in this case, we have an excess demand correspondence, which implies not only the behavior of the households, but also that of firms. And therefore, the property in this context should be explained in a more complex way than in simple consumption theory. However, from a mathematical point of view, the definition is the same. Now, the theorem is the following. If every good is a substitute of every other good, then equilibrium is unique. It is impossible that there are two different price systems in delta such that, or generally speaking, two different price systems such that there is equilibrium both with the first and the second price system. In order to prove this theorem, we must prove initially a lemma, which is important. If every good is a substitute, gross substitute of every other good, then when some price is equal to 0, Z of P is empty. Let us prove this result. If this property holds and P belongs to the non-negative ortant, sorry, it was right in this way. P does not belong to the positive ortant. In other terms, there is at least one good I such that Pi is equal to 0, then Z of P must be an empty set. There are no proper excess demand vector according to this price system. In order to prove this result, Let's consider this graphic. Suppose that good I is the first good. So the first component of P is null. And therefore P will be, for example, in this point. Clearly the other component is a positive number. Suppose ab absurdo that there exists a z in large Z of P. So that tells you that there is an excess Riemann vector according to this P. Now consider the price system lambda times P, where lambda is, for example, in the interval 0, 1. In other terms, when you pass from P to lambda times P, you are reducing proportionally all the components of P. And you obtain a point like this. Is it clear? Let us consider this two-price system. What happens when you pass from P to lambda times P? Since one of the components of P, Pi, in our case P1, is equal to 0, obviously, also lambda times P1 will be equal to 0. If you multiply 0 by any positive number, you obtain another time 0. All the other components, lambda times pk, will be lesser or equal than pk, because lambda is an element of the interval 0, 1. And at least one component, other component, must be lesser than the original one. Otherwise, our two-price system would coincide, and this is impossible. Is it clear? So, substantially, when you pass from P to lambda times P, the height component, in our case, the first component, remains unchanged, while all the others diminish or remain unchanged. At least one must diminish. So, what happens to the demand of good I in this case? The demand of good I must increase. Why? Sorry, must decrease. Why? Because the price of good I remains unchanged, and some other prices diminishes. Since good I is a gross substitute to every other good, the demand of good I, according to our definition, must diminish. So, let us write here, for every Z prime in Z of lambda times P, for every Z in Z of P, Z prime I must be lesser than Z I. But is it possible this result? No. Why? Because when you pass from P to lambda times P, you are altering equiproportionally all the components of P. And therefore, by absence of monetary illusion, the optimal vector, the excess demand vector, must be the same. So, it is impossible that this inequality held, because in this case, you have that real number is inferior than itself, and this clearly cannot happen. Conclusion, Z of P must be empty. Let us repeat the proof. The theorem tells us that if you consider price system with at least one null component, then there are no excess demand vector. The set Z of P must be empty. Ab absurdo, it has supposed that this is not true, that there is a Z in this set. Now multiply the original price system P by a constant lambda. In other terms, alter equiproportional all the components of P. You obtain lambda times P, where lambda is in 0, 1. Note that since the original height component of P is null, also lambda times Pi is null. The price of good I does not change. It remains equal to 0. All the others diminishes or remain equal. But at least one good has a lesser price than before. Now, we can apply gross substitutability. Since good I, whose prices remain unchanged, is a gross substitute to every other good, the sum of the other prices are diminished, this property must hold. For every excess demand vector in the final situation, for every excess demand vector in the initial situation, Z prime I must be lesser than Zi, according to this definition. But this is not possible, because Z of lambda P is equal to Z of P, simply by absence of monetary illusion. When you pass from P to lambda P, all prices change and proportional, and therefore the set of Z remains unchanged. So it is impossible that this inequality held, because in this case you have that excess of demand in the second situation must be lesser than itself, because the same vector appears also in Z of P. Is it clear? Therefore, the result is attained. This lemma has a straightforward consequence. If every good is a gross substitute to every other good, then in equilibrium, the price system must have all positive components. Obviously, because in equilibrium, Z of P is non-empty, or clearly by definition, and therefore it is impossible that some component of a equilibrium price system is equal to 0. In equilibrium, all the components of P must be positive number. So this property, in a sense, is an alternative to strict monotonicity in order to prove that strict monotonicity of preferences, in order to prove that in equilibrium all prices are positive. Well, let us have a short break, and then we shall prove the fundamental theory.